Good morning, Woodrow Wilson Bridge.
The Woodrow Wilson Bridge spans the Potomac River on the outskirts of Washington, D.C., and connects the states of Maryland and Virginia. The bridge carries the I-95, the most heavily traveled road on the east coast of the United States. It also forms part of the congested Washington commuter beltway. The bridge was built in 1961, and its 6 lanes can no longer cope with the enormous volume of traffic. The result is gridlock. The nation's capital is grinding to a halt. It's time for a new bridge. The ambitious plan is to build a monumental 12-lane super bridge, twice as wide and 20 feet higher. It will have to open for river traffic using a bascule or drawbridge mechanism. It will be the biggest bascule bridge in the world. The new Woodrow Wilson Bridge will be the biggest bascule bridge ever constructed. It will carry 12 lanes of interstate traffic, and its 4 gigantic drawspan sections will have to open approximately 70 times a year. It's being constructed on a massive scale. It's costing $2.5 billion and is the biggest transportation project in the U.S. It has 30 separate contractors and over 1,000 workers. This colossal operation is run like a military campaign by former U.S. Army Major General Russ Furman.
It's one of those once-in-a-lifetime projects an individual like myself has the opportunity to be associated with.
Marine engineer Kevin Wickar oversees operations on the Potomac River.
We have a very tight schedule to meet, get the bridge completed initially by 2006. We're currently working almost 24 hours a day. Even through this hot summer weather, we're pushing through, but it's been a struggle. It has.
The bridge site is now waiting for the arrival of the giant drawbridge sections, which are being fabricated over 700 miles away in Florida.
A structure of this size and this complexity, I'm not aware of any other bascule bridge this complex and this large in the world.
When they're completed, the huge bridge sections will have to make a perilous journey up the eastern seaboard of the United States during hurricane season.
The Tug Jaguar is outbound approaching the St. John jetties, checking on any inbound traffic around the St. John jetty area.
In a highly precarious operation, the massive cargo will then be lifted into place, supervised by veteran bridge builder Hokie Del Castello, who sees this as the final challenge of his career.
It's one for the history books. It's a monumental bridge. I mean, this is our nation's capital, and it's going to be one for the history books. I mean, there's a lot of dedication, a lot of hard work. These are the guys out here every day that are building bridges to cross our rivers and level our mountains.
But can a bascule bridge of this size and complexity be built? And how will the massive drawbridge sections be lifted into place?
You ready? Let's go.
1.5.
What? Get with him and get that cable off that bottom flange before it goes in them holes and we got problems.
For the kings of construction, building this monumental bridge is going to be the challenge of a lifetime. The $2.5 billion Woodrow Wilson Bridge on the outskirts of Washington, D.C. is a massive undertaking and is presenting major obstacles for the engineers. Work began on the new bridge in the year 2000. The first 3 years were spent constructing extensive foundations. The whole area was originally a swamp. It's unstable ground and difficult to build on. The approaches to the bridge are on tidewater flats, and the soil had to be consolidated through pile driving in order to carry the weight of the new roads and interchanges along the 7.5-mile construction corridor. When it came to laying the foundations of the bridge, the Potomac River was too shallow for the construction barges to work in, so the river had to be dredged. 500,000 cubic yards of dredge material were removed in order to create a construction channel in the river.
One of the challenges we had here at this site was access to build the bridge itself. Except for the main navigation channel, which we're crossing right about here, which is maintained at about 35-foot depth, all the area to the east was only about 2 foot. So the first thing we had to do was to dig out a construction access channel in this area. The construction methods out here are all marine-based. Everything is basically barge supported. All the cranes, the materials and supplies are all barged out and brought in, and that's how we have to work.
The bridge has also placed other serious restrictions on the engineers, both because of its difficult urban location and because of its unusual design. First of all, the bridge has to be low profile to blend in with the historic city of Alexandria, which is right next to the site. Pressure from local lobby groups has prevented the construction of a high bridge or a suspension bridge, and therefore forced the engineers into making a 12-lane superhighway, which will still have to open for river traffic.
We're in a very populated area, the city of Alexandria, an urban area that's really challenging and tough to construct in, with a lot of human issues. The city wanted to ensure what was there was compatible with the environment that their citizens ought to live in.
The engineers are also being restricted by a variety of environmental and cultural concerns. There's a bald eagle sanctuary right next to the bridge, and a slave cemetery has been discovered on the edge of the site, which is making the contractors reroute the approach roads.
There were 1,879 graves here. In the city of Alexandria, for Black history purposes, we only have 2 landmarks. It's so important because all we have now is just 2 cemeteries, this cemetery and another one, and churches to know that we were here.
The bridge also has to fit in with the monumental architecture of Washington, D.C.
They wanted a signature-type bridge that went with the arches of the other bridges crossing the Potomac in Washington, D.C., so we have that very beautiful arch-type construction that you see out there. Very hard to construct, but aesthetically very beautiful.
The desire to create a modern version of an arch bridge is testing the limits of what can be done with concrete and steel. How is it possible to build an arch shape in modern materials? Crucial to the design is the creation of V-shaped piers, which will support the roadway and form an arch-like structure. However, unlike a conventional arch bridge, where the keystone at the top of the arch deflects all the loads, the V-piers are held together by horizontal concrete girders, which resist all the forces which are trying to split the V-pier in half. The V-piers are constructed out of hollow concrete segments, which are molded in the prefabrication yard on the Maryland shore.
What we have here is the precast segment storage area for the Maryland Approach contract. We had a total of about 650 segments to cast. The casting beds are down the end there, and every piece is somewhat unique.
Work on these massive building blocks is going on virtually round the clock.